Today we're going to look at factoring polynomials, which is in section P.5. Our objective today is to factor by finding the GCF, grouping, and guess and check. So remember, when we're factoring a polynomial containing the sum of monomials means that we're finding an equivalent expression that is a product. So the first thing you always want to do when you are trying to factor is you want to look for a greatest common factor. The greatest common factor, also known as a GCF, is an expression of the highest degree that divides each term of the polynomial. It is the reverse of distributing. So once again, to factor, we're trying to turn things into a product, whereas when we were distributing, we were taking a product and turning it into the sum or difference of multiple terms. So let's dive into some examples. If I'm asking you to factor, like I said, the very first thing that we should be looking for are GCFs. So what do these have in common? In the first one, 10x to the third minus 4x squared, I would start with the numbers. What is the first or the biggest number that 10 and 4 have in common? So obviously 4, you can't multiply to get 10, but since 2 is a multiple of 4 as well as 10, 2 is going to be a part of that GCF. When you're looking at your variables, as long as they have the same base, it's going to be the smaller exponent that they have in common, so x squared. Once I factored out what they have in common, I have to put whatever was left over back into the parentheses. Well, 10 divided by 2 means that there's a 5 left over. And if I had 3 x's, but 2 of them moved out, I still have 1 left inside. I bring down the subtraction sign. 4 divided by 2 is 2. I took out all of the x's there. And notice that what I have in parentheses, 5x minus 2, there's nothing that they have in common. So I know that I factored out everything completely. If you want, you can even go back and distribute that and double check that you get what you originally started with. In the second one, notice that while we've got several sets of parentheses, notice that the parentheses themselves are the same. They're both an x plus 7 within each of those two terms. So that means that that is what those two terms have in common. So if I was to then take out that x plus 7, that means in parentheses I want to put what's left over. Well, what would be left over is what was out in front of those common parentheses. So that would be a 2x plus 3. Notice that within both of those parentheses, there is nothing that they have in common, so we know that we have factored out everything as far as a GCF goes completely. Another type of factoring is factor by grouping. When there are 4 terms and you are asked to factor, we want to group the first 2 terms, group the last 2 terms, and then we look for GCFs within each of those 2 sets of terms. If the remaining terms are equivalent, we'll do just like we did in the last example. We'll factor out what they have equivalent, and then we can finish factoring. So here's my example. Notice that there's 4 different terms. So like the directions said, we're going to group the first 2. I want to group the second 2. If that term or that sign in the middle is not an addition sign, you have to keep that negative with that third term and think of that as an imaginary addition sign in between those 2 parentheses. So now I'm just going to focus on the x cubed plus 5x squared, and I'm going to look for a GCF to factor out. So they don't have any numbers in common, but they have the same variable. So remember, we take out the smaller exponent. That leaves us then with an x plus 5. I'm going to bring that down that addition sign from the middle of those 2 parentheses, and now I'll go to the second set of parentheses and look for a GCF. So when I'm looking at my numbers, I have a -2 and a -10, so they both have a negative in common, and they're both even, so I can factor out a -2, and then that would leave me with an x, but then it would be a positive 5, because remember, if I was to distribute, I got to get back to that -10. -2 times positive 5 will get me that. And the whole point is, notice how, hey, now I've got 2 terms, but they have the parentheses that are the same. So that means I can continue factoring. That's a GCF that I want to factor out. So if I take out that GCF, it's the terms that were out in front that are then left over. And I cannot factor any further, so this would be my final answer. So I would suggest that you pause the video, see if you can try these two checkpoint problems and factor completely. So hopefully you paused, and the first one you saw that the only thing that those two terms had in common was a 7, so I factored that out, and you're left with a 2x minus 1 afterwards. We had a factor by grouping. The nice thing is that they had that addition sign in the middle. Took out the GCF from each of those two. I was able to continue then factoring because they had the parentheses with an x minus 2, so we were able to take out that GCF. We're factoring trinomials whose lead coefficient is 1. So when trinomials look like this, x squared plus bx plus c, so there's no number in front of the x squared, we are asking ourselves what multiplies to c but adds to b. So if we look at these examples, x squared plus 13x plus 40. No number in front of the x squared. If I look for a GCF, I'm not going to find a number in common between those three terms, and they don't all have a variable. So it is important to still look for that GCF first. But if there's no GCF, we're following the directions of what multiplies to the last number but adds to this number here in the middle. So I'm going to create my two parentheses. Since x squared starts us off, I know that x times x is going to get me that. So x needs to begin each of those parentheses. I know everything is addition, so I know that everything will remain positive. And so now let's start thinking about multiples of 40 that then add to 13. So hopefully we're all good with the fact that that would be an 8 and a 5. Now, if you have the 5 and the 8 switched around, that's perfectly fine. It's multiplication, so order of how you decide to multiply those two doesn't matter. So this would be my final answer. X squared minus 5x minus 14. Once again, if I try to look for a GCF, there's no numbers that all three terms have in common. Same thing with variables. So no GCF, no number in front of the x squared, so it's a lead coefficient of 1. So it's just what multiplies to the last number but adds to the number in the middle. So when I start my parentheses, I know that x times x gets you x squared. Because we're dealing with some subtraction signs, I know that how do I multiply to a negative? Well, one of them has to be positive and one of them has to be negative. Now let's start thinking about factors of 14. We got 1 and 14. We've got 2 and 7. So probably 2 and 7 are going to get me close to 5. I want 5 to be negative, which means the bigger number is going to have to be negative. Notice that 2 minus 7 will get you that negative 5, and 2 times negative 7 is that negative 14. Once again, if you decide to put the negative 7 in the first parentheses and the positive 2 in the second, your answer is still the same. Now let's talk about factoring coefficients factoring trinomials whose lead coefficient is greater than 1. I use the guess and check method, and this is how I will always continue to show you factoring. So if your middle school teacher taught you to factor a different way, it's not necessarily incorrect, but this is the method that I will be discussing with everybody. So we start by finding the multiples of A and C. Then we'll check that the sum of the inside product and the outside products add to B. So let me show you what I'm talking about here with these examples. So we've got 6x squared plus 19x minus 7. So notice that we still look for a GCF first. Between 6, 19, and 7, there's no numbers in common, and they don't all have a variable, so there is no GCF. So I have to start by looking at the 6. There's two different ways to multiply to 6. There's 1 times 6, and there's 2 times 3. So I know that one of those sets of numbers is going to start my parentheses, and that's where the guessing comes into play. We have to guess, do we want to start with a 1 and a 6 or a 2 and a 3? So I'm going to start with a 3 and a 2 or a 2 and a 3. It didn't really matter where you put the 3 and the 2, but because they are attached to the x squared, you have to start each of those numbers with an x, because 3x and 2x will get you the 6x squared. Now I look at this last number, and it's negative 7. So that means it can be 1 times negative 7, or it can be negative 1 times 7. So once again, we have to guess which number is going to go then at the end of each of those parentheses. So if I put a -1 first and a +7 second, I now have to check to make sure that I get that middle term of 19x. So I check the outer terms by multiplying them together. Well, 3x and 7 give you a 21x. If I multiply the inside terms together, -1 times 2x is -2x. These are both like terms. If I add them together, I will get that positive 19. So that tells me that we guessed correct the first time around. If you didn't, well, then you would either have to replace the numbers on the back, or maybe it would have been a 1x and a 6x to start us off. Never erase any of your work. Just find the next spot and keep going, because there might be times where if you're erasing, you might be trying the same combination over and over again. So it's better just to not erase, but try in another spot on your paper. If we look at the next one, 4x squared minus 11x plus 6. So once again, looking for GCF, I don't see any numbers or variables in common. Because there's a number in front of the x squared, I have to start there. It's going to be either 1 times 4 or it's going to be 2 times 2. So once again, if I'm trying to determine, because they're both attached, since the 4 is attached to the x squared, I know there's going to be an x with each of those. So, let's try a 1x and a 4x. Now, if you didn't want to write the 1 with the x, you didn't have to. I just did, but you don't have to. Now I'm moving on to the 6. So 1 times 6 or 2 times 3. Because I want to multiply to a positive but add to a negative, I'm going to have 2 negatives, because a negative times a negative will get me that positive. All right, so now we have to guess, am I going to do 1 and 6 or 2 and 3? My end result, I want to try to get the middle to end up being -11. So if I do 3 and 2, I will point this out to you, and so I'm going to say don't erase, but I'm going to erase in a second. Notice that had I tried this, if I look at that second parenthesis, the 4 and the 2, they have a number in common. So that meant that I technically then could have taken out a GCF from that parenthesis. But we had determined at the very beginning of this problem that there was no GCF. So kind of keep that in mind. I can't have the same or a number that is in common in the same parentheses. So that means here the 6 can't go there either, because 4 and 6 have something in common. So that's going to kind of help you with your thought process as well. So I could put like the 2 here and the 3 there, or the 6 first and the 1 second, but there are going to be times that it's going to help you determine how you're going to be doing your guessing. So I've done my guessing. Now I want to do my checking. I'm going to multiply the outside terms together. 1 times -3 is -3, and there's an x with that. I multiply the inside terms together. -2 times 4x is going to give me a -8x. Sorry, my pen's going weird. And then if I add those together, I will get the middle term of a -11x. So I know that I factored that correctly. 3x squared minus 13xy plus 4y squared. So once again, the only thing that's different about this is that now there's 2 variables, but the thought process is still the same. So let's look for a GCF. They don't all have numbers in common. They don't all have variables in common. There's a number in front of the first term. Luckily for us, it's a prime number. So I know that there's only one way to multiply to get 3x squared. So it's going to be a 1x, and it's going to be a 3x. And once again, you don't have to write the 1 with the x. If I look at the last term, I've got a 4 in front of a y squared. Well, I know 4 is 1 times 4 or 2 times 2. But notice that because there's that variable at the end and it's a y squared, I know I'm going to have a y with each of those numbers at the end. Because it's addition at the end, but I want to have a negative number in the middle, I know that both these things are going to be negative. So once again, this is where your guessing is coming into play. So if I was to guess 1 and 4, if I put like the 1 first and the 4 second, well, now I have to check to see if I get the middle term. Notice that if I multiply the outside terms, I'm going to get a -4xy. If I multiply the inside terms, I'll get a negative 3xy. That's not going to add up to my middle term. So once again, I'm not going to erase. I'm just going to try it again. I know that the first term is going to have to stay the same because there's only one way to multiply to 3. But now we're going to have to then either flip-flop the 1 and the 4 or go with 2 and 2. So what I'm going to do is I'm just going to switch around the 1 and the 4. So I'm going to have the 4y, and then I'm going to have the 1y. So now if I check, 1y, or 1x times negative 1y is a negative 1xy. And now if I multiply the inside terms, negative 4y times 3x is going to give you a negative 12xy. If I combine those like terms, I will get that middle term. And so this would be my final answer. Once again, I would suggest that you pause the video and try these 2 checkpoint problems. First one, you should have gotten this. If you have the negative 9 and the positive 5 switched around, perfectly fine. Here we had to do a little guess and check. Notice that there were 3 different possibilities for numbers for 16, but if you just keep plugging in numbers and then checking the middle terms, you will see that 5x plus 2y times the quantity x minus 8y was your answer. Difference of 2 squares. If a and b are real numbers, variables, or algebraic expressions, then we know that a squared minus b squared is always going to factor into a plus b times a minus b. So we know difference of 2 squares, so perfect square. So anytime you see those perfect square numbers like 4 and 16 and 25 and all of those, then we know that, hey, we might have a difference of 2 squares. There is no number in front of the x squared, so it's technically a 1. So that just means that I get to start off each of my parentheses with a 1x and a 1x or an x and an x. Because we know that we then have a negative sign here to multiply to a negative, one of those has to be positive and one of those has to be negative. But since there's no middle term of x, that's why it's nice that we have this perfect square number, because then we'll have the same number in the parentheses where then they would cancel out, which is why there is no middle term. Hopefully we're okay with its 9 times 9 to get us 81. And here would be our factored answer. In the next one, I should have told that for number 9 as well, but you still want to keep looking for that GCF. So if there's anything in common, factor that out first. There's nothing in common between a 36 and a 25. Notice that 36, though, is a perfect square, and 25 is a perfect square. So 36 would be 6 and 6, so I'm going to make it a 6x and a 6x. We've got a positive and a negative because that multiplies to a negative, and 25 is 5 times 5. Once again, if you double check by multiplying the inside and outside terms, you'll see that the middle terms ends up canceling, which is why there is no middle term. Okay, pause the video, see if you can do this problem. All right, hopefully we're okay with having this for our final answer. All right, here's our last example. Notice that we have 81x to the 4th power minus 16. So notice that 81 and 16 are perfect squares, just like the examples that we previously did. The only thing that's different in this example is that it's not an x squared term, it's an x to the 4th term. So we still are able to think of this as a difference of 2 squares. It's just that this x to the 4th, when we are creating our factors, we have to think of it as not x and x, but x squared and x squared, because x squared times x squared will get us back to x to the 4th power. 81 is a perfect square, that's 9. So like I said, now it's a 9x squared that starts off our parentheses. We have to have one addition and one subtraction sign. 16 is a perfect square, that is 4 times 4. Now, once we've done this, we have to check to see if we can continue factoring here, because we have these x squared terms in each of those parentheses. Because 9 and 4 are perfect squares, we could potentially keep going and doing the difference of 2 squares. But the first parenthesis has an addition sign. I'm not going to be able to factor that. However, the second parenthesis has a subtraction sign. I will be able to keep going there. So the first parenthesis will stay as it is, but now I get to break up that second parenthesis into 2 more parentheses. 9 is 3 times 3, but now we just get to put an x with it because x times x will get us back to x squared. And then we have to have an addition and a subtraction sign to multiply to that negative, and 4 is 2 times 2. Notice 3x plus 2 and 3x minus 2 don't have anything in common, so I can't factor any further. So then this would be my final answer. All right, so that is what I wanted to cover today. Please let me know if you have